We have been solving quadratic equations for what seems like forever. And unfortunately, we haven't had very much time to solve sort of real world problems. We're going to look at a few of those today. There are many, many, many more applications for quadratic type problems. And so we're going to just look at this one type of quadratic problem today. So, on your notes, you see this equation right here. This is for a dropped object. If I take an object and drop it, what's going to happen to it? It's going to fall down. Have you ever dropped an object and it went up instead of down? Of course not. Why does it go down? Because of gravity. And the negative sign right here in the formula is because it's going to go down. This 16 in the formula is the constant due to gravity. Now, how many of you are in physics right now? You have done these same kind of problems, but you did not have a 16 in your problem. Probably in physics, you had a 9.8 t squared or a 10 t squared, depending on how you rounded it. Why is it different? Mostly in physics, if you are using the 9.8 number, it's because you are working. Gravity is not different in physics class, in math class. It's still gravity. It didn't change from upstairs in the physics class. The difference is in this formula, we are measuring in feet. The 9.8 is meters per second squared. But what is this? Feet. Feet per second squared. And also you can put down here by the time in this formula, the time here in this formula is measured in seconds. And so this is the formula for an object that is simply dropped. Now, what does the H stand for? There's two H's. What is the difference between this H and that H? What does initial mean? This is where you start. And this one is where you end. And so that's the difference in the two H's there in the problem. And the 16 is because of gravity, and the negative sign is because my object is going to go down. Oh, and since t squared makes it quadratic, it's going to have the shape of a parabola. But where is the other half of my parabola? Why is that half of my parabola cut off of my picture there for the graph? What is this axis down here now? It's not X. What is it? Time. Does it make sense to have a negative time? Am I going to drop this and it's going to go backwards in time? It's not going to happen in this universe, and so that's why we don't have to worry about that half of my parabola. So Cheyenne is on top of a 144-foot building, and she drops an object over the edge. So where's it going? And how long is it going to take to hit the ground? And so this is the equation for a dropped object. Where was it to start with? Will we all agree that that's a height? Is that the height where it started or the height where it ended? And so this is going to be the 144-foot number. Where's it going to end up? If it hits the ground, what is the height on the ground? Do you know? If it's on the ground, it would be 0 height above the ground. We're finding the x-intercept. When you are finding at what time will it hit the ground, you are finding the x-intercept. We could find that by completing the square. But since is there a b in this equation? Since there's no b, there's actually an easier way. All I want to do is solve for t. So if I'm going to solve for t, what am I going to do with the 144? I'm solving for t. What am I going to do with the negative 16? And so that's going to cancel out. And what do you get when you divide that? Did it come out to be 9? I'm solving for t. What am I going to do to get rid of the squared? And so what is t equal to? T is also equal to negative 3. Because whenever you take a square root to solve an equation, you get a plus answer, a positive answer, and a negative answer. But in the context of this problem, does it make sense for time to be negative? No. And so that's what I was telling you the other day. A lot of times we ignore that answer because it doesn't make sense for the context of the problem. Now, there's one more thing I need. What is t? Inches, feet, miles, gallons, minutes, seconds, hours? It is seconds, and it needs to be labeled. When you have a word problem where there's a context around that number, it needs to have a label. All of your answers will have labels. This is a continuation of the same problem. So she's still on top of the building. She dropped it down. But now we're asking a different question. Instead of how long will it take to hit the ground, how long will it take to be 6 feet above the ground? So this is still 144 because she is still up there on the top of the building. Now, where does the 6 go? What is the 6? This height. And so this will not be 0 this time. It will be 6. That's how high we're trying to figure out. Okay, so what do we do with the 144? What do we do with the negative 16? And so t squared is going to be equal to what number? 138 divided by 16. On your homework paper in a minute, it says that you're supposed to round your decimals to 3 decimal places. So we'll go ahead and do that on our note paper also. And so now what do we do to solve for t? Now, in the context of a word problem, it often does not make sense to simplify the answers. We're going to decimalize the answer because that makes more sense with the context of the problem. So we're going to go ahead and use decimals because this is a word problem. Make sure you label your answers with a unit. Roy is on a cliff 16 feet high. Directly below him is deep water. He dives into the water. At what time will he be halfway to the water's surface? Where does the 16 go in my equation? What? It's the height where he starts. So that is going to be the 16 feet that goes with it right there. Now, is this going to be 0 this time? Are we trying to figure out how long it takes him to hit the surface? No. So what number goes over there? What is halfway to the water's surface? 16 divided by 2 is 8. Halfway. So we're still solving it, and so we're solving for this. So what do we do with this 16? We're solving for the t. What do we do with this 16? Cancel, cancel. We're solving for the t. What do we do with the squared? We do not have to worry about the negative answer when we take the square root because it doesn't make sense with regard to this problem. The rest of the notes we're going to do tomorrow. So right now we're going to switch over to your homework paper. On your homework paper, please notice it tells us how we're going to round our decimals. And so Madison is on the roof of a building that is 576 feet high, and she accidentally drops her purse. And if she drops her purse, it's going to fall to the ground. And on this paper, go ahead and write this at the top of this paper because this is the equation that we're going to use on all problems that are dropped. This is only the equation for dropped problems. Now, would we agree that's the height? Where is that 576 number going to go in my equation? It's going to be the last number in my equation. So down here in this answer blank, this is going to be negative 16t squared plus the 576. Now this middle space in here says sketch the function. Make the graph, in other words. This axis over here is going to be the height in feet. This axis down here is going to be the time in seconds. How high does it start? This is going to start at 576, and it's going to go down. And why did I make it look like sort of like a half of a parabola? Looks like a parabola because t is squared. It's only half of a parabola because we ignore the negative time part. Everybody got that much? So now that we have this equation, when will the purse hit the pavement? If it hits the pavement, how high is it going to be? Please solve this on the right answer. You're going to subtract this, divide by this, and then take the square root, and the answer was 6 seconds. So continue on with the next problem.